Okay, ladies and gentlemen, here we go. Another segment AB. Using segment AB, we're going to do some more bisecting. Now, do remember that if we want to bisect this segment, we want to put one center down here on one end, and we want to choose a point. Now, I'm going to choose this point all the way at the end so I know where to find it. But as long as this point is over halfway between the two. So here we go. Uh-oh, I hope my paper's big enough. Here we go. So I've done it from one end. Let's go to the other end. Put it on the end, and let's make a mark. Whew, okay, just big enough. And by having these cross over, we can now make this bisector. So now C, we can confidently say C is a midpoint. And C is a midpoint by def of bisector. Okay. We can also say AC is congruent to CB by construction. Okay. We can now also say, as we talked about previously, that here we go. These two lines totally make a perfect right angle, just like the box of this Kleenex is. So we have a perfectly right angle. So now I can say, if I call this point up here D and this point down here E, I can say that DE is perpendicular to AB. Now, folks, if I have made a segment that is perpendicular and bisects, that means, and this was by construction, what I've made is I can say that DE is a perpendicular bisector of AB. So DE is a perpendicular bisector of AB. And that would be by def of perpendicular bisector. All right. Now that's really good because now I can say, hey, that angle's 90, that angle's 90, that angle's 90. And now we can start talking about other properties. Here we go again. We've talked about this previously. If any point, A, B, C, D, E, F, any point on a perpendicular bisector, and F could have been here, it could have been here, 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 doesn't matter where it was. Any point is equidistant. Try not to use my ruler so that you know I'm not cheating. That distance there, AF, should be the same distance as FB. Now, just for giggles, let's take a look. F to A is 4 1/4 strong. This is 4 1/4 strong. And those two indeed match. So we would say AF is congruent to FB because we would say point on perpendicular bisector equidistant from each endpoint. So we have that. Now this becomes important because now we can make triangles. Even more importantly, we can say lots of things about these triangles. I already know that this line is congruent to, or this segment is congruent to this segment. I already know that segment is congruent to that segment. I also know that this is congruent to itself by reflexive. So what's true about this triangle half and this triangle half? That means they're going to be congruent by side, side, side. All right. Well, we can go even better than that. Let's look at the big triangle. The big triangle has two congruent sides, which means that base angles are equal. So you can say by definition of isosceles triangle, base angles are equal. Because we already proved each triangle congruent, you could also say those two angles are equal by CP/CTC. All of these things start to come and pile up. Do you see that as soon as we can create equal segments and then equal angles, and then we can bisect those segments and bisect those angles, Now we can begin constructing all sorts of things. And among them, we can create perpendicular bisectors. And those things can be used in forward or used in reverse, but it's nothing more than a perpendicular bisector construction. Now, additionally, this same idea can be used to create altitudes. It can be used to create altitudes. If I want, I have a segment, and I have some point up here that is not on that segment, A, B, C. At this point, I want to create a line down to this point right here, or down to this line right here, but I don't want it necessarily to be a perpendicular bisector. I want a line that goes through C, but that is perpendicular. And the way I do that is very simple. I simply find my compass, and any place where I can make an arc that intersects the original twice. It intersects here and here. Now, what's going to be true about this? Congruent, congruent. And now I also know this angle and this angle are congruent. So if I could just find a bisector and cut this point in half, wouldn't that make a perfectly good triangle? Well, I can. Let's pick something over halfway between my points. All right, now I'm using the one right past the 1.5. So let's use the one right past the 1.5. And again, by creating one arc, I make it the same distance each way, which means when I create a bisector, it should go right through that point that I wanted. Now, this is important because not so much that this equals this, although that's fine. What's most important is that this is a right angle. If this were not 3 individual points, but were originally actually a triangle, what I just did was I dropped a line from that vertex to this side that's perpendicular. That is called altitude. So I constructed an altitude. So I can construct perpendicular bisectors. I can construct altitude. I can construct angle bisectors if I wanted. And the only other thing that I haven't created is what's called a median. A median is between any 3 points. I can draw a triangle. And just to be careful here, I will draw the triangle. Now, a median is what you might think. It goes down through the middle of a triangle. Now, but the middle means what I want to do is I want to draw from A to the center of BC. Now, I could attempt to do it without it and try to figure out, well, where would the center of BC be? I don't know. But the easiest way to do it is actually to just simply bisect or find the midpoint between C and B. So here again, I'm going to go over halfway. There's a mark. Oh, I need to know which one I used. It's the one right here. So it's halfway between those two. And it's halfway between those two. So I do this. And if I do that, I can create a segment. But I don't really want the dotted line. I just want the midpoint. I just want this to know that ABCD, that BD is congruent to CD. And if I connect the dots between this, I have now created a median that goes from a vertex to the middle of an opposite side. So I can construct altitudes, angle bisectors, perpendicular bisectors, and medians. And now we're going to start putting them all together.